Let's take a look at some more examples of different levels of measurement. And just a reminder, nominal, ordinal, interval, and ratio are our levels. Generally speaking, nominal and ordinal work with qualitative data or categorical data, and interval or ratio are generally for quantitative data. A, high school soccer players classified by their athletic ability, superior, average, above average. Well, we definitely have qualitative data here. We have categories, and in this case, we can order them, so we have ordinal data. Baking temperatures for various main dishes, 350, 400, 325, 250, 300. These are likely degrees Fahrenheit on an oven, and since they are temperatures are quantitative, but 0 degrees Fahrenheit does not mean no temperature. This is an interval level of measurement. Colors of crayons in a 24 crayon box. We have categories. We have the different colors, but we cannot order them per se. So we have a nominal level here. One could argue that we could order crayons, the colors of crayons, by the spectrum, wavelengths. That's getting way too technical for us though. So we're not going to order them, we're just going to let them be nominal. Social security numbers for D. Social security numbers are 9-digit numbers unique to every citizen in America. They are numbers, but those numbers are not indicative of a count or a measure. Quantitative data must be a count or a measure. Social security numbers are randomly generated 9-digit numbers, so they are not a count or a measure. This is qualitative data. Also, whether we can order them based on numerical properties, we could, but the order is not meaningful other than placing and ordering on them. We may be able to rearrange the social security numbers based on where the people were born, because similar social security numbers are representative of where you actually applied for the number, where in the country you applied for the number. So the ordering doesn't really make sense. This is another nominal level of measure. Incomes measured in dollars. Well, this is definitely quantitative data. It's money, so we have numbers. Does $0 income mean actually zero? No money? Yes, it does. So we have ratio level. F, a satisfaction survey of a social website by number. 1, very satisfied. 2, somewhat satisfied. 3, not satisfied. Even though the numbers are there, these are categories. The numbers 1, 2, and 3 are not a count or a measure of anything significant. It's just a label. So we have qualitative data here. That qualitative data could be ordered, so we have ordinal level for F. Political outlook, extreme left, left of center, right of center, and extreme right. Well, even though there's sort of an order listed on here, the order isn't really meaningful because we could flip it around. Extreme right, right of center, extreme left. We could say extremes versus moderates. So we don't have a universal ordering. This is nominal. H, time of day on an analog watch. So the time of day, this could be 3:58 p.m. It could be 4:23 a.m. We have a lot of different options for time of day. So we do have a number, and it is measured because it's on a watch. The watch is measuring the time of day. Now determining interval or ratio, we have to determine, is there a natural zero? Is there a zero that means no time? Well, for time, similarly to temperature, there is not. So time is an interval level of measurement. There is a difference between the times 3:58 is 5 minutes later than 3:53. So we have a subtraction that makes sense, but we don't have a natural zero. I, the distance in miles to the closest grocery store. Distance is measured in miles. 0 miles means you live in the grocery store. So that 0 is meaningful. We have a ratio level of measurement. Dates: 1066, 1492, 1644, 1947, 1944. We have some random years given to us. So we have numerical data. We could say 1947. It is perfectly valid to say 1947 is 3 years after 1944. So we have a difference. Do we have a year 0? It turns out we don't. Whether we look at Common Era and before Common Era, CE and BCE, we go from 1 before Common Era to 1 Common Era. There is no 0. And we can't say something like the year 1400 is 2 times the year 700. That doesn't make sense. And so for dates, we have an interval level of measurement. It's very similar to the time of day on a watch. So time in many aspects, the time of day, the years that we have, these are interval levels of measurement. If we were measuring how long it takes to do something, that's a different kind of time. We're actually measuring from 0 to how long it takes. So the 0 does make sense. It may take me twice as long to wash the dishes than my husband, for example. And so if that's the case, the 0 does make sense. It takes me no time to do it. It's done. So just be really careful when you're looking at the data, what type of time it is. Here, time of day on a watch, dates, these are interval levels because the 0 does not make sense. In K, the heights of 21 to 65-year-old women, we are talking about heights and we are measuring, and 0 height actually does mean 0. We would not have a person with 0 height, but the 0 height is meaningful. If you had someone who was 3 feet tall and someone else who was 6 feet tall, we could say that the 6 foot tall person is twice as tall as the 3 feet person, and you can see the ratio there, twice as tall, or the 3 foot person is half as tall as the 6 foot person. The ratio is meaningful between them. And so for heights, we do have a ratio level of measurement. And then last in this example, common letter grades A, B, C, D, and F. These are definitely qualitative data. We don't have numbers, we have letters. Qualitative, breaking it into categories. Can those categories be ordered? Yes, they can. Universal ordering is given right there. And we have different types of levels of measurement. Hopefully in identifying with these examples, it helps you understand the differences between nominal, ordinal, interval, and ratio levels of measurement.